Assalamu alaikum wa rahmatullahi wa barakatuh. This is, as you see on the screen, this is sticks for the tent. When you wanna build a tent for camping, you have to use those sticks to make the tent stable. Most of the stick goes into the ground, and the more it goes into the ground, the more powerful the stick will be. This is for, the tent, as you all know. Okay? That we have to, the more the stick goes into the ground, the harder it becomes to take the tent off from the wind. If a wind blows, the tent will be stable because the sticks around the tent will keep the tent stable. The Quran described the mountains in the Quran as الجبال اوتادا, and he made the mountains as sticks. Someone asked me how the mountain they are as sticks. Why the Quran described the mountain as sticks? The reason, to understand that very deeply, you have to understand what's called the mountain forming and the concept of isostasy concept, which is right here, as you see in the book for geology, concept of isostasy. This is the concept you have to know in order to know why are mountain high. Okay, it's a process that we should understand in order to understand how the mountain act like a sticks. Okay, let's read the concept. 1 second. Read current page.
9.6 mountain topography 285 already floating.
The lower block would sink to adjust for the addition, so as to maintain isostatic equilibrium. From our bathtub experiment, we can deduce that any phenomenon that changes the thickness and / or density of a floating block will affect the elevation of the block's surface above the water surface. Since the lithosphere floats on the asthenosphere, the elevation of the lithosphere's surface depends on the thickness and density of the lithosphere. So to answer the question of why mountain belts can rise, we must identify geologic processes that can change the thickness and / or density of layers in the lithosphere. Let's consider some examples of how these changes take place. Crustal shortening and thickening. During collisional orogeny or during certain types of convergent margin orogeny, horizontal compression causes the crust to shorten.
Okay, this is the book for the name of the book I'm using. I'll give you the book name so you know. I'm on chapter 9. You have to go to chapter 9 in order to understand the mountain topography, how the mountain form, mountain topography. And let me give you the book name, this way you know what I'm talking about. Page cover, just to go to the cover. This is the book I'm using, Essentials of Geology, the 4th edition, by Stephen Marshark. Okay, when you go to chapter 9, chapter 9. Yep, chapter 9. Mountain topography. Right here. You need to start reading from. If you gotta understand a lot of concepts in this book and in other book which is called Fluid Dynamics, in order really to understand how the mountains act like sticks. Okay, I'm just trying to show you how to search for that. Okay, that's regarding the book. You'll find that in the Mountain Topography, chapter 9.6 in that book which is I just showed you. And I'll put the book. You need to read this book in order to understand how the elevation of different crust, and you need to know the different densities of those different layers of the earth. Okay, in order to understand how the mountain really acts like a sticks. That's in general. Going into details is gonna take more than one video, but this is just for someone who wants to search the topic, how the mountain acts like a sticks. كيف تقوم الجبال بأنها تكون اوتادا كالوتد أن تميد بكم, in order not for you to feel the unstable of the plate tectonics. There is instability sometimes occur because of earthquake, but that's not all the time. But most of the time the plate tectonics, they are stable because of isostasy. And to understand this isostasy concept, you need to understand fluid mechanics, geology and geophysics, in order to understand it deep enough to really appreciate this creation of Allah subhanahu wa ta'ala. But for normal people, just you should know that the mountain, the cause of the mountain actually is the collision between the two plate tectonics, and one goes beyond lower than the other, and the push of buoyancy, that's really, and the friction that what caused the. Let me try to search for you a picture so you know what I'm talking about. This is another sticks right here. You know, this is not really going all the way in the ground, but if you want to make this stick more firm, you just hammer it to the ground. And let me show you the subduction zone I'm talking about. Okay, subduction zone. Subduction zone. Subduction zone. Because that will help you understand how the mountain really form. Yeah, this is how a volcano form. You see, this picture show you how the volcano form. This is the oceanic crust. This is the lithosphere, and the movement of plate tectonics, one coming from this side, the other one is coming from this side. So they collide, and this one goes in the bottom, but it doesn't really, sometimes it doesn't give you this space from here. You see this space right here, it's not really accurate because you have a buoyant force is pushing on this layer too. So this layer will be sticking to this layer right here, and there will be friction here, and because of the friction and because of the subduction, so you have one force coming this way, one force going this way on this line. Why this right here, this layer will be right over here. Okay, let me see if I could draw on the picture. Why? Because of the buoyancy, and that will cause the mountain to form. Because there is a buoyancy force is acting on the both lithospheres, this lithosphere and this lithosphere. So the buoyancy force is acting on both lithosphere from the bottom. Which bottom? This bottom. You see where's this arrow? There is an arrow upward that way. That's why this layer will go along here, and that will cause friction, and that will cause the mountain to form. I hope I find another picture explains what I'm talking about. I'm just searching. Just give me a second. Subduction zone. See this picture? Yeah, this is a subduction zone. You see over here, they are touching each other. Okay, subduction zone, earthquake. Because the earthquake over here, you see how this layer is touching in this red line. Why? Because there is a buoyant force is acting upward, and that will release the mountain upward and downward. Okay, and that's called isostasticity concept, according to Archimedes' principle, and that's why the mountain forms. Maybe I'll find another picture will be more helpful. Over here they're showing you how the volcano form, because there's a drop of water and they will make pockets, and these pockets will go up, then steam will come out, then later will become, this heat will melt the crust, and that's what how volcano form. That's another mountain, which is Volcano's Mountain. But I'm talking about, yeah, let me see here. You see, this is a subduction zone. It has to touch the upper. See, this is plate subduction. What's subduction? It's being recycled. Why it's being recycled? Because the other parts of the earth, where is the sea floor spreading, a new plate tectonic is being born, and the sea floor spreading. That's why it's being recycled from. It's been some plate tectonics is dying and being recycled here, and other places in the sea floor is being created. So you need to understand the cycle of the plate tectonics in order to understand how the dynamics of the plate tectonics, how plate tectonics in some places they are being subducted, and other places in the seafloor spreading is being created. Earth as a whole, plate tectonics, they are in dynamic movement through time, through geological time. So that's another benefit you need to know. So basically you need to study geology, and you need to study the buoyancy physics and and fluid mechanics in order to understand how the mountains is forming. You know, this is a different issue over here, the cracks. You know, there is plate tectonic going that way, and there is plate tectonic this way, and that will cause a trench over here. That's another issue. Okay, but one thing you have to understand, that the density of the mantle is higher than the density of the crust, and that's why the plate tectonics acts like a ship floating on the sea of mantle. All the plate tectonics, and that's why they move. That's why they used to be in Pangea, and they are being separated gradually year after year, and that's the theory of plate tectonics. The theory of plate tectonics is based on that the density of the mantle is higher than the density of the solid rocks. So the ground you are walking on, they are floating over the sea of the mantle, like the iceberg is floating on the water. So they follow the same kind of fluid dynamics laws. And this is, if you want to understand how mountain really form, you need to study that. You need to study fluid mechanics, continental drift, how mountains form, all of that, in order to really deeply understand how the mountains form. جزاكم الله خيرا. I'm gonna take a break and come back inshallah.
الأرض مهادا والجبال أوتادا.
من الآيات السالفة الذكر يتضح لنا معنيان. المعنى الأول إن الجبال أوتاد شكلا، إذ إن قسما من مادة الجبال يغرق في طبقة القشرة الأرضية. والمعنى الثاني إن الجبال تشبه الأوتاد دورا، أي أنها تعمل على تثبيت القشرة الأرضية وتمنعها من أن تميد وتضطرب. أما المعنى الأول فقد اكتشف علم الجيولوجيا الحديث أن طبقة القشرة الأرضية السيال، والتي تظهر أمامنا على الشاشة وهي الطبقة التي نعيش عليها، هي التي تشكل القارات وتحتضن المحيطات وترتفع جبالا في مكان وتنخفض وديانا في مكان آخر. وتلي هذه الطبقة مباشرة طبقة السيمة، وهي أكثف من طبقة السيال، ولكن تحت ثقل هذه الأخيرة يصبح لها قوام عجيني، الأمر الذي يسهل انزلاق القارات عليها. فالقارات جميعها تنزلق بسرعة ملحوظة وباتجاهات متعددة حسب القياسات الحديثة للأقمار الاصطناعية. جاء في كتاب الأرض Earth لفرانك بريس إن الجبال الضخمة لا ترتكز على قشرة صلبة، إنما هي تطفو على بحر من الصخور الأكثر كثافة. وبمعنى آخر إن للجبال جذورا أقل كثافة من طبقة السيمة تساعد هذه على العوم. ويقول العالم فان أنجلن في كتابه جيومورفولوجي الصادر عام 1948: من المفهوم الآن أنه من الضروري وجود جذور في السيمة مقابل كل جبل في طبقة الأرض كما هو واضح أمامنا. ولنفهم هذا التوازن نأخذ مثلا الجليد، فالجليد أقل كثافة من الماء، كما أن السيال أقل كثافة من السيمة، فإن علا جبل الجليد فوق الماء فلا بد من امتداد له تحت الماء يدفعه على العوم، وكذلك الجبال. وكذلك هو الحال بالنسبة إلى السفن البحرية، فلا بد للسفن من جذر غارق في الماء يدفعه إلى أعلى ويساعدها على الطفو. هذا الذي ذكرناه هو بالنسبة للمعنى الأول. أما المعنى الثاني وهو أن للجبال دورا في تثبيت القشرة الأرضية، كما يثبت الوتد الغارق في الأرض الخيمة كما هو مبين في الصور. هذا المعنى لا يزال من الناحية العلمية ضمن إطار البحث والجدل، وإن كنا نجزم به بورود النص القرآني الصريح